today's lesson is on scientific notation. And scientific notation is a way to rewrite really big numbers in a shorter fashion. So here we have the following number. We've got 5 million. How are we going to put it in scientific notation? The first step is to identify that scientific notation must be in the following format. The value is always in some fashion, such as m times 10 to some power of n. And the letters don't really matter. You can use whatever letters you want, but there are certain rules that need to apply for these letters. This value m, right, cannot be greater than 10 or smaller than 1. So in other words, 1 is the smallest number that the m value can ever be. So it's 1 is less than and equal to whatever that value of m is, but that m value must be less than but not equal to 10. So maybe you might not understand this format, right? But a simpler way to figure this out, or to identify this, is that the smallest number we can ever have is 1. So 1, any number between 1 and a number of 9.9999 to go on forever. So that is the biggest number you could possibly ever have in the value of m in scientific notation. So you'll see things like this. You might see 2 times 10 to the power of 3. You might have 4.7 times 10 to the power of negative 8. But you can never have something like this, 0.9 times 10 to the power of 3. You see this 0.9? That 0.9 is not within this range of numbers. Another example of where we have to fit that rule is if you have an answer like this, let's say 12.5 times 10 to the power of 4. Notice here this value, this is what we call the m value, and that number is beyond 9.999. Okay? So we have to make sure that when we have incorrect formats to what we think is scientific notation, we must be able to change these, and we'll talk about those later on. Now, how do we change this number, 5 million, into this format? Well, the first thing to do is you're looking at the number, and I like to compare numbers as really big numbers, like 5 million, and really small numbers like 0.00092. That's a really, really small number. So, scientific notation is a way to kind of simplify numbers that are really, really big or really, really small, or even regular numbers. You can even convert something like the number 57 into scientific notation. So anyway, but let's go back to this example. We have a really big number, and with really big numbers, the most important thing you want to identify is where do you place the decimal? Where do we find the decimal technically in this first number? And because it is a whole number, the decimal is always furthest to the right if we don't see one. Right? So that's technically where the decimal really is. Actually, let me use a different color to show. Hopefully you'll be able to see it. I'll try to draw it a little bit bigger. That's really where the decimal is. Okay? We want to move that decimal to the furthest to the left. Okay? And we always want to find the very first digit on the opposite side. So the very first digit, which is the only real digit here, is 5. So we want to place that decimal, right, this decimal here, we want to place it immediately following the very first digit. Right? Because remember what we said about this m value. This m value must be between 1 and 9.99 repeater. Right? So 5.0, or 5 itself, is within this range. So now, this is where we want to put that decimal. This is where we have the decimal in our question. How many places do we move it? So we're going to move it 1 place, 2 places, 3 places, 4, 5, 6 places. The movement of that decimal is represented by this n value. So whatever the number of places that we moved it at, that is going to be that value. So our n value is 5 times 10, that never changes. That's our base. And our n value are the number of movements in which we've moved our decimal to our new place. So we moved it 1, 2, 3, 4, 5, 6 places. So the n value is 6. So here we have the number 5 times 10 to the power of 6. And usually whenever you have big numbers, or what I call big numbers that are whole numbers, greater than 1, you always have a positive value for your n. Let's look over at the smaller number, and we already know where our decimal is. So what we want to do is we want to identify what my m value is. We want to identify what the n value is, because in return we are going to substitute that number in that. So this is the format that we want scientific notation. So let's figure out what the m value is. So first things first, we want to move our decimal. We already have the decimal because it's a really small number. We want to move it immediately following the very first digit that we appear. So zeros, we don't count the zeros. These are just placeholders. The very first significant digit, or digit that we're going to be looking at, is 9. So we want this decimal immediately following the 9. So that 9.2 is our m value. 9.2 is our m value. Let's find out what our n value is. So, how many places have we moved it? 1, 2, 3, 4, 5 places. But because we moved it to the right, we are moving it in a negative direction. So it's negative 5 places. So our m value is 9.2, our n value is negative 5. So instead of m times 10 to the power of n, what's m? Our m is 9.2. Our n is negative